Good day, dear students. Today's theme is electrostatics. We have studied mechanics, molecular physics, and now we are starting new part of the physics, which is called electromagnetism. What about electromagnetism? Electromagnetism can be explained by electricity, magnetism, and optics. And in this table you see some analogies between three parts. For example, charge can be an analogy of electric circuit and a reflection in optics. Force in electricity, magnetic field in magnetism, and refraction in optics. Field in electricity, induction in magnetism, and image in optics. Potential in electricity, alternating currents in magnetism, interference in optics. Current in electricity, magnetism, waves, and diffraction in optics. So here's our new vocabulary. For example, charge – заряд, current – ток, excess – артық, лишний, deficit, жетіспеушілік, нехватка. This is due to the electrons. For example, excess electrons, deficit of electrons. Silk, жібек, шелк. Attract, тарту, притягивать. Repel, теблю, отталкиваться. Equilibrium, тепе-теңдік, равновесие. Permittivity, өтімділік, проницаемость. For example, what about electric charge? For example, we in nature observe the transfer of charge. For example, let's consider the silk and the glass rod. If the glass rod is rubbed against silk, electrons are pulled off the glass into the silk. This is the main property of the matter. For example, you know the structure of the atom. Atom contains nuclei, consists of protons and neutrons, and around the nuclei rotate electrons. Nuclei has positive charge, and the electrons are charged negatively. When the glass rod is rubbed against silk, electrons are pulled off the glass into the silk. For example, then after in silk there are excess electrons. So the silk is charged negatively. And in rod it is a deficit of electrons, so the rod is charged positively. You see the next process, and after we will consider that the glass and the silk are insulators. Charges stuck on them stay put. And what about insulators? In matter we have next types of conductors. First, conductors. They have free electrons and the electric current can pass through conductors. Second are insulators. Insulators have not free electrons and the electric current cannot be transferred through insulators. Semiconductors and superconductors. About semiconductors and superconductors we will study in the next course of physics. In nature we have two types of charges, positive charge and negative charge. Two positively charged rods repel each other, so the like charges repel each other. For example, two negative rods also repel each other. Here is the history of the study of electrostatics, and by this we can discuss about that the history of electrostatics started from the ancient times. This is a summary. There is a property of matter what is called electric charge. The unit of electric charge is coulomb. Charges can be negative or positive. Electrons have negative charge. Protons have positive charge. The positive charge are stuck in the nuclei. Matter is negatively charged when extra electrons are added and positively charged when electrons are removed. Like charges repel, unlike charges attract. Charges travel in conductors, not in insulators. And the force of attraction or repulsion inversely proportional to the square of the distance between charges. What about charge? Charge consists of electrons. Electron is an elementary charge and its value is 1.6 multiplied 10 in minus 19 degree coulombs. In this table you see the charge, mass and the diameter of different charges. Electron has negative charge, proton positive, neutron 0, positron positive charge. But the masses of electron and the positron are the same, diameter are the same, but they are different in their charges. And you see that the heaviest particle is the neutron. What about Coulomb's law? If we have two charges in the space, they will interact with each other because there is an electric field. If in the space one charge, it will be the electric field. And by the electric field, they can interact with each other. They can attract each other or repel. This process is called interaction of charges. And the force of attraction or repulsion can be defined by the Coulomb's law. Here you see the Coulomb's law. The force between two charges equal K multiply Q1 multiply Q2 per square of distance, where K it is the constant 9 multiply 10 in 9th degree, Q1 and the Q2 the values of two charges, R is the distance between two charges. And the K can be derived as 4 multiply P multiply epsilon 0 in minus 1 degree, whereas epsilon 0 is the permittivity of free space. 8.86 multiply 10 in minus 12 degree. And if we consider the hydrogen atom, you know that the hydrogen atom consists of proton and one electron. And we know the masses of electron and the proton and the distance between electron and the proton in the hydrogen atom. We can calculate gravitational force and the electric force. Gravitational force we can calculate by the law of gravitation, and it's equal 3.6 multiplied 10 in minus 47 degree newtons. And the electric force can be calculated by the Coulomb's law, and it's equal 3.6 multiplied 10 in 8th degree newton. You see that the electric field is more, that the electric force is more than the gravitational force. Let's consider three charges. Blue charges here on the figure, you see blue charges are fixed and they are negative and they are equal, and the red charge is positive. And we know that the on positive charge can be attract the blue charge. For example, here is the force that is attracted on the side of blue charge to the red charge. Here is the force between this blue charge and this red charge. And the superposition of this can be explained by the vector diagram, and we can add two vectors. And here is the net force. For example, superposition principle. For example, you see Q1, Q2, and Q3, and here is the force between Q2 and Q1. Here is the force between Q3 and Q1, and F is the net force. Forces add vectorially. This is the main principle of electrostatics. For example, you see gravity, you see two balls, and you see that there is some angle between two charges and they have equal mass. And what are the forces? For example, these charges are equal, so they repel each other, so it is electric force to one ball, so it is electric force to second ball, and T, it is a tension, and we see that it is electric force and gravity, and so we can define the net force. Net force can be defined as the vectoral adding of these forces. So it is your homework to calculate or to derive the net force acting on these balls. So if you have some questions, you may write to some systems such WhatsApp, such Viber, and others. So thank you for your attention.